Welcome to the lecture entitled The Pragmatic Account of Scientific Explanation. I'm Andrew Chapman. In this lecture, we'll discuss 8 topics. 1. How to investigate the nature of scientific explanation. 2. The deductive-nomological model of scientific explanation. 3. Problems for the necessity and sufficiency of the deductive-nomological model's criteria. 4. Syntax, semantics, pragmatics, and their relation to explanation. 5. The pragmatic account of scientific explanation. 6. How the pragmatic account is an improvement over the deductive-nomological model. 7. Worries. Is the pragmatic account scientific? Does it trivialize explanation? And 8. Philosophical lessons and taking stock of the pragmatic account. In investigating the nature of scientific explanation, it's important to notice that most people take science to offer a particular sort of explanation. There's good reason to think that one of the things that separates different explanatory disciplines, that is, disciplines that give explanations, from one another is the sorts of explanations given. Thus, the sort of explanation given by an explanatory discipline can serve to demarcate that discipline from other explanatory disciplines. Even further, however, there's good reason to think, and most scientists certainly do think, that the explanations given by science within its particular domain, namely the domain of natural phenomena, are better than competing explanations given by non-scientific disciplines. Thus, science claims a sort of priority over explanations of natural phenomena since science claims its explanations are the best ones available of natural phenomena. An investigation of scientific explanation is an inquiry into the nature or essence of scientific explanation. In order to search for this nature or essence, we should start by analyzing the notion of scientific explanation. Such an analysis of the notion of scientific explanation will result in an explication of explanation. An explication is a completed analysis of a thing, and explications, as their name implies, make explicit the nature of that thing by providing the necessary and sufficient conditions for something to count as that thing. Thus, when searching for the nature or essence of scientific explanation, we should attempt an explication of the notion of scientific explanation. This explication will result in the necessary and sufficient conditions for something to count as a scientific explanation. The classical model of scientific explanation is known as the deductive-nomological model of scientific explanation and was articulated most fully by Carl Hempel. According to Hempel, any scientific explanation must meet all of the criteria of the DN model, or else it isn't a real scientific explanation. That says that all of these criteria are necessary for something to be a scientific explanation. And anything that meets all of the criteria of the deductive-nomological model is a scientific explanation. That claims that together the criteria are sufficient for something to be a scientific explanation. There are 4 criteria that are individually necessary, that means each one of them is required, and jointly sufficient, that means together anything that has all of those things is. a scientific explanation, and these are individually necessary and jointly sufficient for something to be a scientific explanation. These are: 1. The explanation must be in or be able to be put into the form of a valid deductive argument in which the conclusion of the argument is the explanandum, the thing being explained, and the set of premises of the argument is the explanans, the thing doing the explaining. The explanans must contain, that is, one of the premises of this argument must be, a natural law that is actually needed in the logical deduction from the explanans to the explanandum. 3. Each of the members of the explanans, that is, each of the premises of our argument, must be empirically testable. And 4. Each of the members of the explanans, that is, each of the premises of our argument, must be true. There have been a number of criticisms of the deductive-nomological account of scientific explanation. Most of them come in the form of challenging either the necessity of all four of these criteria or the sufficiency of the group of criteria. Let's look at one of each, a challenge for necessity and a challenge for sufficiency. A counterexample that challenges the necessity of the deductive-nomological model's four criteria is one that claims that the criteria are too narrow, that they don't capture all things that are scientific explanations, and thus there are things that don't meet all of those criteria that are nonetheless scientific explanations. Even if there are many scientific explanations that cite laws, there seem to be many scientific explanations that don't cite laws at all. Consider explanations from history concerning why a particular war occurred, or explanations from sociology concerning why a particular social group fractured, or explanations from psychology concerning why a person developed the phobia that they did. All of these seem like perfectly acceptable scientific explanations, but none of them cite laws. If there can be scientific explanations that don't meet all of the deductive-nomological model's criteria, then not all of those criteria are necessary for something to be a scientific explanation, and those criteria don't capture the nature of scientific explanation. A counterexample that challenges the sufficiency of the DN model's four criteria is one that claims that the criteria are too broad, that they capture things that aren't scientific explanations. Consider the flagpole shadow counterexample that's attributed to Sylvan Bromberger. If we know the length of a flagpole shadow, the angle of incidence of the sunlight to the flagpole, and some facts about how light travels and how trigonometry works, then we can determine the height of the flagpole. What that means is that we can create a valid deductive argument whose conclusion is a statement of the height of the flagpole, whose premises contain laws, how light travels, trigonometry, and whose premises are empirically testable and true. Those are the four criteria that are jointly sufficient for something to be a scientific explanation, according to the deductive-nomological model. Thus, according to the DN model, we can explain why the flagpole is the height that it is by referencing the length of its shadow. That's explain it, not just derive it or figure it out. Of course we can figure it out, but even further, we can explain why it is that height by citing those other facts. But that's exactly backwards. The length of the shadow is explained by the height of the flagpole, not the other way around. If there can be things that meet all four of the deductive-nomological model's criteria, but that are not scientific explanations, then those criteria are not sufficient for something to be a scientific explanation. Thus, it seems like the DN model's four criteria are both too narrow and too broad. They're not individually necessary and they're not jointly sufficient for something to count as a scientific explanation. The DN model is a syntactic model of scientific explanation in that it's concerned only with the structure of a scientific explanation. It says that there's nothing more to scientific explanation than producing something that has the right components in the right places. Thus, even a simple computer that was properly programmed could create DN-style explanations, and this was supposed to be a feature of the DN model, not a bug. One of the goals of the DN model was to make things as objective as possible, to keep out any potentially biasing subjective human influence. However, scientific explanations, even though they're directed at the objective world, are human-centered things. Humans request, develop, and employ scientific explanations, and as such, a model of scientific explanation that entirely ignores the essentially human component of explanations is missing something that's necessary for explanations. While the structure of an explanation is of course important, the context of the explanation matters too. And this is what's ignored by the deductive-nomological model. Imagine that somebody shows you a blueprint for a building. The blueprint shows floors and rooms and windows and doors and everything else that would be necessary to know how to put one of these things together. In short, the blueprint shows the structure of the building. Now, just from looking at the blueprint, do you know which part is the top of the building and which is the bottom? Well, of course, you might say the part with the doors is the bottom and the part on the opposite side is the top. Of course. But where did you get this information from? How did you know that doors go at the bottom? That information wasn't gleaned from the blueprint itself. You brought that knowledge to your understanding of the blueprint and interpreted it in light of this knowledge. When you're only provided with the structure of something, no matter how detailed that structural description is, it's impossible for you to determine the orientation, the directionality of this structure. You need more information, contextual information, to determine orientation. The DN model is concerned primarily with syntax or with structure of explanation, and as the flagpole example showed, merely having a determinate structure leaves the orientation indeterminate. It allows us to reverse the normal order of explanation and to claim that the length of a flagpole's shadow explains why the flagpole has the height it does, etc. One of the philosophers to recognize the importance of context in scientific explanation is Bas van Fraassen. Van Fraassen is a professor of philosophy at Princeton and at San Francisco State University. He's primarily a philosopher of science whose work has been guided by empiricist and pragmatist commitments, although he is not an extreme empiricist or extreme pragmatist in the way some other philosophers of science are or have been. Since we'll be using the term pragmatics quite a bit, as well as the related terms semantics and syntax, let's get clear on what all of those terms mean. In linguistics, the terms syntax, semantics, and pragmatics capture different components of meaningful items like words and sentences. However, these terms, especially syntax and pragmatics, can be extended to non-linguistic items as well. A thing's syntax is its structure. A sentence's syntax is its grammar. An explanation's syntax is the relation of all the parts of the explanation to one another. A thing's semantics is its meaning. A sentence's semantics is what is being talked about and what is being said about that thing. The term semantics doesn't directly or easily apply to explanation, although we could make it apply to explanation by saying that an explanation's semantics is the world or the part of the world that the explanation is talking about. A thing's pragmatics is its relationship to the context in which it's embedded. So a sentence's pragmatics is the time, the place, the speaker, etc. of that sentence's production. And an explanation's pragmatics is the time, the place, the asker, the answerer, etc. related to that explanation's production. The terms pragmatics and pragmatism are used frequently in philosophy and the philosophy of science, so it's important to keep them conceptually separate from one another. While these terms have closely related etymologies, they're both concerned with practice and action. They don't mean the same thing, and confusing them with one another will make an already complicated set of topics much more complicated. Pragmatics, as we've noted, is the situation, temporal, spatial, etc., that a thing is embedded in. To take pragmatic features into account is to take context into account. Pragmatism, on the other hand, is an overarching investigative methodology that measures the value of questions and answers in terms of their practical consequences. Followers of pragmatism are known as pragmatists. To add to the confusion, unfortunately, oftentimes philosophers who talk a lot about pragmatics are themselves pragmatists of some stripe. But we can't assume just because somebody is concerned with pragmatics that they're a pragmatist, or because they're a pragmatist they're concerned primarily with pragmatics. These are two separate things conceptually. The DN model of scientific explanation was concerned only with the structure of explanation. Structure is an abstract property, and it wasn't concerned at all with the people asking for and giving explanations. Those were concrete situations that were irrelevant to the DN model. According to the DN model's criteria, even a well-programmed simple computer could produce explanations, so people are irrelevant. However, Van Fraassen recognized that conceiving of scientific explanation in terms of mere structural abstraction left out essential components of what scientists were and are actually doing in asking for and giving scientific explanations, and that even further, the sort of structural abstraction that was present in the DN model was not what scientists even ought to be up to, since ignoring contextual factors in theorizing about explanation makes it impossible properly to analyze the notion of scientific explanation. Thus, Van Fraassen's solution was not only to just add in contextual pragmatic factors, but further to make such contextual factors primary to all other factors, structural factors included, in the account of scientific explanation. If explanation starts and ends with the behavior of people, then nothing but a person-first methodology would do. Note that such a person-first methodology introduces subjective factors into the notion of scientific explanation, and thus that this methodology is a fundamental break with the animating ideas. We might think of them as objectivity and only objectivity that were the foundation of the DN model. We can see that the notion of pragmatics is helpful in understanding certain features of human behavior, but do we really need to be concerned with it here? Aren't we concerned only with truth in science, and can't we make sense of truth purely in terms of meaning and structure, that is, purely in terms of semantics and syntax? Well, consider the following example. In answer to the question, have you stopped selling stray cats to Chinese food restaurants? If I'm only concerned with saying the true thing in response to that question, the correct answer on my part is simply no, since I've never sold stray cats to Chinese food restaurants and hence I can't stop doing it. However, this answer on my part would be misleading since it would lead interlocutors to believe that at one point I did sell stray cats to restaurants and I'm still up to it. However, this conclusion on the part of my interlocutors that I did at one point do it and I'm still doing it isn't logically implied by my saying that I haven't stopped selling cats. It's not implied by the syntax or the semantics. What it is pragmatically implicated by my saying so. Pragmatics then, and hence context, seems essential for understanding. And since explanation is plausibly seen as a sort of understanding, or something that leads to understanding, pragmatic elements must similarly be involved in the notion of scientific understanding. That is, there's more to understanding than structure and meaning. There's also context. According to Van Fraassen, a scientific explanation is a telling answer to a why question. When we ask, why did such and such occur, or why did the occurrence of such and such have so and so properties? What we're asking for is a scientific explanation. The answer to these why questions is a scientific explanation. Why questions, that is, demands for scientific explanation, are distinguished from one another by three features. That is, what makes some particular why question the why question that it is and not a different why question is three features of that question. Those features are the topic of concern, the contrast class, and the relevance relation. So, to reiterate, if you take some why question and you change it by varying even one of these three features, you end up with a different why question. It's also important to recognize that these three features are internal to and essential components of the why question. So these three components are not yet part of the scientific explanation. The explanation's an answer to the why question, and these three are just parts of the why question. Notice that by focusing as much as he does on the components of the why question, Van Fraassen's primary concern is with the asker and with what's asked in the process of demanding and providing scientific explanation. This switch from answer to question is a hallmark of the pragmatic account and one of the central differences between it and competing accounts. For example, the DN model wasn't concerned at all with the request for an explanation. Its necessary and sufficient criteria were all about the answer. Let's look at these three features in turn. First, consider this question. Why did the iPhone crash to the floor? So here's a why question. The topic of concern is whatever it is that the question is asking about. This will often be some event that occurred, but it could also be a property possessed by an object or the existence of some object at all. In our question, we're asking about an event that occurred. The iPhone crashing to the floor. Why did that happen? So our topic of concern is the iPhone crashing to the floor. And notice that if we changed the topic of concern, so if instead of being concerned with the iPhone crashing to the floor, we were concerned with the wallet crashing to the floor, or the iPhone falling into the pool, etc., we'd end up with a different question. So changing that topic of concern changes our question. Again, our question is, why did the iPhone crash to the floor? When we ask for a scientific explanation, we do so because something has surprised us. The contrast class determines precisely what it is that has surprised us and in what way we're surprised. The contrast class is a set of all relevant possibilities that could have happened involving our topic of concern, including the possibility that actually did happen. So an example here. This is the set that contains the iPhone crashed to the floor, the iPhone levitated, the iPhone shot into the air. The contrast class is an instead of class. Why did this happen instead of that other thing? Without understanding the contrast class, we can't fully understand what's being asked. So in that first contrast class that we've given as an example, what we're saying, according to that contrast class, when we ask why did the iPhone crash to the floor, is why did the iPhone crash to the floor instead of levitating, or instead of shooting into the air, or instead of whatever else the other relevant possibilities are there. That shows us what it is that we're surprised about and in what way we're surprised. Consider a couple of alternative contrast classes to make this clear. In this contrast class, we have iPhone crash to the floor, wallet crash to the floor, keys crash to the floor, etc. So, if this second contrast class were what determined what we were surprised about, then what we would be saying by the question, why did the iPhone crash to the floor, is why did the iPhone crash to the floor rather than the wallet, rather than the keys, etc. Or consider a third example. In this contrast class, we have the iPhone crash to the floor, the iPhone floated softly to the floor, the iPhone transported to the floor. So if this third contrast class correctly described what it was that we were surprised about, when asking the question, why did the iPhone crash to the floor, what we would be asking is, why did the iPhone crash to the floor rather than float softly to the floor, rather than transport to the floor, etc.? So what the existence of the contrast class shows us is that a why question is ambiguous until you determine the correct contrast class. Why did the iPhone crash to the floor can be read in a number of different ways depending on what you're surprised about. So I might be saying, why did the iPhone crash to the floor? Or why did the iPhone crash to the floor? Or why did the iPhone crash to the floor? And those different contrast classes emphasize different parts of that why question. Again, our example question, why did the iPhone crash to the floor? The relevance relation is the relation that stands between the asker and a potential answer, and it determines which potential answers will count as acceptable explanations for the particular asker in her particular circumstances. So consider, if I ask why did the iPhone crash to the floor while we're all sitting around eating pizza, a very brief description of how gravity works would suffice for me. I'm not a physicist. I would probably just need gravity makes things fall when they're unsupported. Got it. That's an acceptable explanation for me, and what determines that it's an acceptable explanation is the relevance relation. However, if a researcher of quantum gravity asked the same question, some very complicated answer would probably be required. The answer that would be acceptable for me would be unacceptable for her, and the answer that would be acceptable for her would be unacceptable for me. And what determines whether an answer is acceptable or not for a specific person in particular circumstances is the relevance relation, which is a component of the question. While all three of the components of a why question, topic of concern, contrast, class, relevance relation, have contextual components to them, the relevance relation is entirely contextually determined, and so is doing a lot of work in the pragmatic account. So those are the three components of a why question. But of course, we haven't even talked about an explanation yet. As we've noted, the pragmatic account is much more focused on the question than it is on the answer. However, it is the answer that's the explanation. So why are we paying so much attention to the question, to the request for explanation, rather than the explanation itself in an analysis of the notion of scientific explanation? The main reason for focusing so much on the question and not the answer, according to the pragmatic account, is that understanding the notion of explanation is easy once we understand the notion of a request for explanation. An explanation is simply a telling answer to a why question, and such a telling answer is just one that's accepted by the asker in accordance with the three features of the why question, especially in accordance with the relevance relation. So we can see that the pragmatic account is almost completely asker-centered. It's the asker who determines the particular question, including the specifics of all of its features, and it's the asker who determines whether some answer to that question is a telling answer, whether it's acceptable as a scientific explanation. The pragmatic account can be seen as a direct response to the problems with the DN model. While the pragmatic account makes a number of improvements over the DN model, three broad sorts of improvements are most salient. The first is that the DN model has a very strict set of necessary and sufficient conditions for something to count as a scientific explanation. This strictness makes it easy to find counterexamples to the DN model, and we've already seen two counterexamples, although there are many others. The pragmatic account has one and only one criterion that is both a necessary and sufficient condition for something to be a scientific explanation, and that's a scientific explanation is a telling answer to a why question. Second, one of the perennial problems for the philosophy of science is being so abstract in its theorizing that its theoretical results don't match actual scientific practice at all. The pragmatic account is based on and takes as its foundation the concrete practices of actual scientists. And third, because context is of primary importance in the pragmatic account, and since contextual features are situated in both space and time, the pragmatic account can make sense of the directionality, that is, the directions in space and directions in time, and more broadly, the orientation of scientific explanation, which is something that the DN model couldn't do. So, for example, the pragmatic account would have no problem at all with the flagpole example because an asker wouldn't take an answer to the question, why is the flagpole that high, that came in terms of the length of its shadow as an acceptable answer. Now we've seen the motivation for the pragmatic account, we've seen what the account says, and we've seen how it makes improvements over the DN model. But of course there are some worries with the pragmatic account. One of the reasons we care about the nature of scientific explanation in the first place is that most people think both that there's something unique about scientific explanation and that this uniqueness results in the superiority of scientific explanations to other sorts of explanations in many cases. However, the pragmatic account demands no restrictions either on the type of why question that can be asked in science or on the type of telling answer that can be given. This openness, which is in some respects a virtue of the pragmatic account, has also led a number of critics of the pragmatic account to claim that the pragmatic account isn't a theory of specifically scientific explanation, but instead that it's a theory of explanation in general. The most obvious way to fix up the pragmatic account so that it's an account of specifically scientific explanation would be to add in some demarcation criterion that acts as a test to sort the sorts of answers to why questions and the particular why questions that are allowed to count as scientific. However, notoriously, attempts to discover a demarcation criterion have so far failed. Thus, if the pragmatic account isn't an account of scientific explanation, but is an account of explanation in general, then the simplest way, the most obvious way to try to fix it up is blocked to us. So we would need some other way of fixing up the pragmatic account so that it's not just an account of all explanation, but an account of scientific explanation. Let's think for a moment just about the notion of explanation in general. Why care about figuring out what explanations are? The obvious reason is because explanations are special sorts of things that, when employed properly, can bring about understanding and can increase knowledge on the part of those employing those explanations. Thus, not everything is an explanation. Only some things, the things that bring about this particular sort of understanding and knowledge, count as explanations. However, recall the third feature of why questions, the relevance relation. This relation determines what will count as an acceptable explanation, and it's entirely contextually determined. What this means is that for any particular why question asked by some specific person, what counts as an answer to that question is whatever that person will accept as an answer. The answer doesn't need to increase actual understanding, it doesn't even need to be true, and in fact, it doesn't even need to be words. If I'll accept a high five in response to my why question, then according to the pragmatic account, a high five is as good an explanation as anything else. What this means is that anything and everything is an explanation, and thus that according to the pragmatic account, explanation isn't something special, something unique, something better than other sorts of things. All things are explanations. But a number of critics have noted this threatens to trivialize the entire notion or concept of explanation. It's not as though we can say, oh great, now everything is an explanation. Explanations are everywhere, because if explanations are everywhere, then these critics have noted that trivializes explanation. If explanations were important because they were rare and special, because they did something unique and important, then any account that says that explanations are whatever you want them to be simply destroys the importance of explanations and trivializes explanation. There is a historical tendency for the response to an extreme position to also be an extreme position, albeit on the opposite end of the ideological spectrum. Thus, for example, we often see that toppled far-right dictators are replaced by a far-left government. And this is exactly what's happened in the historical dialectic between the DN model and the pragmatic account. The DN model was far too objective, too abstract, too strict, and too merely structural. The pragmatic account responded to these problems by being too subjective, too concrete, too loose, and too contextual. When the metaphorical pendulum has swung too far in one theoretical direction, we should expect the response to be a swing too far in the opposite theoretical direction. One benefit of this historical tendency is that after the first two swings have been completed, we can look for a third solution that lies about in the middle of the two extreme positions. Scientific methodology is normative in that it prescribes steps to the scientist. It says, in order to do good science, you ought to follow these particular steps. Thus, an investigation into scientific methodology, which is one of the main projects of the philosophy of science, is normative in nature. A perennial problem for the philosophy of science has been how to do justice to actual scientific practice, which has, let's admit, been very successful, without simply turning into the merely descriptive history of science. Successful philosophers of science need to perform a delicate balancing act between the normative and abstract on the one hand and the descriptive and concrete on the other hand. Philosophers of science who pay too much attention to the normative component of the philosophy of science end up producing accounts of scientific methodology that are too abstract and that don't do justice to actual scientific practice. Take, for example, Hempel and the DN account. Philosophers of science who pay too much attention to actual scientific practice end up producing accounts of scientific methodology that are merely descriptive, they're historical, they just describe, and that are too concrete and not sufficiently normative. So take, for example, Van Fraassen and the Pragmatic account. So it's probably the case that without significant alterations, the Pragmatic account is not an account of specifically scientific explanation. That is, it's an account of all explanation in general, and even worse, that it trivializes the notion of explanation by making anything and everything, even things that aren't sentences like high fives, acceptable scientific explanations. So if we're looking for an account of specifically scientific explanation that doesn't trivialize the notion of explanation, we might want to look somewhere else. But we should be careful not to throw the baby out with the bathwater here. Van Fraassen's insights, especially in terms of the contextual embeddedness of scientific explanation, will be important for any account of scientific explanation that does justice to explanations as human-centered things that are requested and produced by humans. Even further, Van Fraassen's recognition that the nature of explanations relies on human practices and doesn't simply float free in some abstract realm returns the discussion of scientific explanation to the concrete world of practicing scientists. In this lecture, we've looked at 8 topics. 1. How to investigate the nature of scientific explanation. 2. The deductive-nomological model of scientific explanation. 3. Problems for the necessity and sufficiency of the deductive-nomological model's criteria. 4. Syntax, semantics, pragmatics, and their relation to explanation. 5. The pragmatic account of scientific explanation. 6. How the pragmatic account is an improvement over the DN model. 7. Worries. Is the pragmatic account scientific? Does it trivialize explanation? And 8. Philosophical lessons and taking stock of the pragmatic account. Thank you.